Hi everyone, today's video is going to cover the second day of 4.2, so we're going to be graphing lines from a table. So if you remember in our last video, we were creating solutions to a linear equation using a table. And so we're going to build on that today to actually be able to graph the equations, or graph each of these equations in the coordinate plane. So here's how we're going to do it. The first part of the process is going to be just what we've done before. So we're going to create a table to help us find three solutions to the equation, right? And when we say that, when we get three solutions, we're really going to get 3 points on the graph. So once we have those three solutions, or the 3 points, we're going to plot the corresponding coordinates on our coordinate plane, and then we're going to draw a straight line through the 3 points, and that will be the graph of each of these linear equations. So let's go ahead and get started. Now you'll notice my table here doesn't have the x values filled in, so I can pick whatever values I want. And I generally will pick -1, 0, and 1, because they're easy numbers to work with. So if you remember, just like we did yesterday, if I want to find the y value that corresponds to an x of -1, I'm going to take my original equation, y equals 4, and for x, I'm going to plug in -1. And I get a -4, which is going to go in my y value here. So really what I've just done is I've found out that the point -1, -4 is going to be on my graph. So I'm going to do the same thing for my other two x values. Now I have y equals 4 times 0, which is going to give me 0. So I know that my graph goes through the point 0, 0. Remember, that's our origin, just to review some vocabulary. And then for my last one, y equals 4 times 1 gives me a +4. So now I've generated 3 solutions to that equation. So now we can go down to our coordinate plane here. I'm going to adjust this so we can see the table and the coordinate plane. And I'm simply going to plot these 3 points. So first, -1, -4. Remember that tells us we start at the origin. We go 1 to the left and down 4. My second point is at 0, 0. And then my third point is at 1, 4, which tells me to start at the origin, go to the right 1, and up 4. And if I did this correctly, all of those points should lie on a straight line. If they don't, that tells me I did something wrong with my calculations. So now, please use a straight edge, your ID, or something. I don't want to see any curvy lines here. You're going to use that straight edge to connect those 3 points. I'm going to draw arrows on both ends to show that line goes on forever and ever in both directions, and that's the graph of our equation. So that's how we're using tables to graph these lines. So now, my second one, it's the same type of problem. This one maybe looks a little trickier because it has a fraction, but it's not a big deal. I'm just going to be a little more strategic maybe about how I pick my points. So I'm going to pick, let's see, I'm going to pick a -4 because I have that fraction of 1/4, and I don't want to create points that have fractions in them. So I'm going to pick -4. I'm going to pick 0. That's always a nice, easy one to work with. And then I'm going to pick +4. So here's what's going to happen. I have y equals 1/4. When I multiply that by a -4, right, I could check in my calculator. Oops. I have 1/4, and I'm going to multiply it by a -4. And that's going to give me a -1, so that's going to make it nice and easy to graph. So my corresponding value is a -1. My second point is y equals 1/4 times 0. That's going to give me a 0, so that's easy. Again, I'm going through the origin there. And then the last one, I have 1/4 times 4, and that's just going to give me a +1. So again, remember, these values in my tables just gave me 3 ordered pairs. So I have -4, -1, 0, 0, and 4, 1. So now I'm going to zoom this up here so we can see the table and the coordinate plane, and I'm just going to plot those points. So starting at the origin, I go left 4 and down 1. My next point is 0, 0. And then I go over 4 and up 1. And again, I can do a quick check, know that I'm correct, because all of these points lie along a straight line. So I'm going to use my straight edge to connect them and draw the arrow at either end. All right, so go ahead and pause the video and try the next one, and then you can check your answer when you're done. All right, so here is the solution to this problem. So again, I just picked -1, 0, and 1. Even if you put different values in here, your graph should look the same. You might have plotted 3 different points, but the line should look exactly the same. Again, my line is going through the origin. All right, so let's move on from there. I'm going to get refocused here. Now, we're doing the same thing here. Our equations just look a little bit different. So now we have, let me refocus this again. Now we have our variable, some variable term, but we're also adding a constant. Now that's not going to change the process that we're doing at all. So I'm just going to stick with my -1, 0, and 1. So to get my y, I have y equals -4 times the -1 plus 2. Please be sure to be very careful of those signs. So I have a -4 times the -1 plus 2. That's going to give me a +6. Okay, same thing here. Y equals -4 times 0 plus 2 gives me a +2. And lastly, -4 times 1 plus 2 is a -2. So again, I've just generated 3 ordered pairs. I'm going to put them off to the left. So I have -1, 6, 0, 2, and 1, -2. So I'm going to go ahead and plot those ordered pairs. Oops, and actually I guess that wasn't a great one because you'll notice I went off of my graph here, but we'll kind of make it fit. So it would be about up here. Sorry about that. Then 0, 2, and then I have 1, -2. So again, I'm going to connect those up with a nice straight line, and there's our graph. Okay, go ahead and try, we'll jump to the last one here. Go ahead and try that with -1, 0, and 1. So you can pause it, and then I'll walk through it after you unpause it so you can check your work. Okay, so I'm going to plug it in just like before. I'm a little tight on room here. I'm going to write over here. So I have y equals -2 times a -1 minus 1. If I plug that into my calculator, I'm going to get +1. For my next point, I have -2 times 0 minus 1. So that's going to give me a -1. And then if I plug in a +1, I should get a -3. So my points are going to be -1, 1, 0, -1, and 1, -3. So now we just have to plot our points and connect them up. And we have our graph. Now, one thing I want to point out about all the problems that we've done so far is you may have noticed that y is always been by itself on the left-hand side. So in all three examples, y was by itself. And if you remember, we called that function form. And it made our equations really nice and easy to work with. Now, in these examples down below, you'll notice that we're no longer in function form. These equations look a little bit different. And so for this set of examples, I'm actually going to go ahead and put these in function form first before I go ahead and create my table and graph. And so we'll do a couple examples of what that would look like. So remember, our goal is to get y all by itself. So we're going to use those skills we learned when we were solving equations to do that. I know that if I want y by itself, I need to move this x over to the right-hand side. Since this is a positive x, to do that, I'm going to subtract x. So now my x's cancel here, and I get a y. And now I'm going to switch the order a bit. I'm going to take my negative x here, I'm going to put that first. So y equals negative x, and then I'm going to bring down my positive 2. And I'm going to be really careful since this has an x and this does not. We don't have like terms, so I need to make sure I have my negative x and also my positive 2. And now graphing is just like it was before. I'm going to pick my 3 points. And for each one, I'm going to plug it into my equation. Now, since I have this negative, I have to be a little bit careful. I'm going to have y equals my negative, but then in parentheses, I have a negative 1 plus 2. So if I take the opposite of negative 1, or negative times a negative 1, that gives me a positive 1 plus 2, and that's a 3. Then I have y equals negative, well, really we don't have the negative of 0. Still 0 plus 2, so that's just equal to 2. And then y equals negative, my x is 1, plus 2 is a positive 1. And so then I can go ahead and graph those 3 points. So I have negative 1, 3, 0, 2, and 1, 1. Okay, so let's try another one. Again, remember my first step, my goal here was to have y by itself. So in order to do that, I need to move this 5x over. So since it's a positive, I'm going to do the opposite, and I'm going to subtract 5x. So now my 5x is gone, and I get y equals, I'm going to take my negative 5x, and then I bring down my positive 4. So that would be that equation in function form. Now, I need to be a little bit careful here. For this one, I'm just going to use, let's see, what's going to fit here. I'm going to use 0, 1, and 2. And we may end up a little off of the grid, but that's okay. So let's see what happens. I have y equals a negative 5 times 0 plus 4. So that gives me a positive 4. For my next point, I have negative 5 times 1 plus 4. So a negative 5 plus 4 is a negative 1. Then I have y equals negative 5 times 2 plus 4. So I have a negative 10 plus 4 is a negative 6. So here's where we're going to go off of the coordinate plane a bit. So let's see what this looks like. I have 0, 4, 1, negative 1, and then 2 is going to be about down here, 2, negative 6. So again, draw our straight line through and connect the dots. Now, for the last one, what I really want to do is we're not going to worry about creating the table and graphing. I just want to focus on getting this one in function form because this has a little extra step in it. So remember, my job is to just have y by itself. And I'm going to have to write small to fit this in. First thing I need to do is I still need to subtract x to move that over. So when I do that, this goes away, but now I have to be careful to make sure I bring down this negative y. And that's going to be equal to my negative x minus 4. Now, if you notice, my y still isn't by itself. I have this negative 1 here. And we know to get rid of that, we need to divide by a negative 1. Now I need to be careful. I need to divide everything on the right-hand side by negative 1. So when I do that, the negatives cancel, and I get y is equal to, well, here my negative divided by negative makes that a positive x, and then a negative 4 divided by negative 1 makes that a positive 4. So my equation in function form will be y equals x plus 4. And to graph that, we would follow the same process that we've been using with the table. So that's where we'll leave it for today. In the next video, you'll be learning how to graph specific types of lines.